Right, so with the proportionality theorem, we basically want to prove that AD over DB is equal to AE over EC. That's our aim. Okay, that's what we want to try to prove. Because for the proportionality theorem, when you get a line drawn parallel to one of the sides, we say it divides these two sides proportionally. Okay, so AD over DE should be equal to AE over EC. So what we're going to do is we're going to try to prove that if we take the area here and divide it by the area there. Okay, let's say we make this area for this triangle blue. And let's say we make the area for this triangle EDC, let's make it red. Okay, as you can see, that's the two areas we're going to use, the blue triangle and the red one. And then we're going to use this whole triangle at the top. This whole triangle at the top, we're going to use this one. That's the three triangles that we're going to use. So if we can show that the area of triangle ADE divided by the area of triangle DBE is equal to the area of triangle ADE divided by the area of triangle DEC. If we can show that, then we can use that to show that AD over DB is equal to AE over EC. And that's kind of the bigger picture of what we're going to try to do. Okay, so let's start by saying area triangle ADE divided by the area of triangle DBE. And we can say that's going to be half times the base. Okay, half times the base, but then which one is the base? So what we're going to do is we're going to say we want AD to be the base because we want AD over DB. So we have to make AD the base and then we need the height. So that means from AD we must go straight towards the top of E. Okay? And that's your construction line. Okay? You must put in this construction line in the test when they give you the question. You put in this construction line. And then you call that construction line the height for this triangle. So call it H1. Say this construction line is H1. It's the height for this triangle. Okay? So then it's going to be half times the base, AD, times the height, which is H1. And then we're going to divide it by the area for DB, which has a base DB. So it's going to be half times the base DB times the height, which is the same. Because think about it, triangle DBE, there's the top, there's the vertex, E. From the base, you need to go this way and then go straight up to vertex E. So the important thing is that both these triangles has the same height, H1. So we're going to say H1 again. Okay. It's important to understand that for the proof. They share, this one and that one shares the same height. Now when you simplify this, the H1 and H1 cancel out, the half and the half cancel out, and all you're left with is AD over DB. So it's equal to AD over DB. And then you can put in a reason here for what you said. You can say, okay, they've got the same height. Okay, they've got the common height. Why? Because they share the same vertex E. Okay, both triangles share a common vertex E, so they get the same height. Common vertex E, so they get the same height, which is H1. Okay, so we did that part. Now we're going to do the same thing, but we're going to go to the red triangle and again triangle AD. So we're going to say now area of triangle ADE again, but now divide by the area of triangle DEC. Area of triangle DEC. So now we're going to say again the same thing, but now because we want to look at AE and EC, these two sides now. Remember we already looked at AD and DB. Now we're going to look at AE and EC. So now we're going to make AE the base for the triangle. And that means from AE we need the perpendicular height. So now we can draw a line this way, a construction line, and say there's the height H2. Let's put it in there, H2. So now this is your construction line. So you need two construction lines for this question. H1, the perpendicular height for this. H2, the perpendicular height for that one. So it's the same triangle, but the first time we made AD the base, the second time we make AE the base. So we're going to say it's half times AE now, times the height, H2. And now if you look at triangle, the red one, DEC, you can say the base for this one is EC and the height is also H2, as of the previous one, where we went this way. So we're going to extend EC until we get to the perpendicular height. Okay, so we're going to say half times EC times H2, the height for that triangle, and then they cancel out, half and half cancel out. So now we got it's equal to AE over EC. Okay. So now the important thing is, remember what we want to try to prove is we want to try to prove that AD over DB is equal to AE over EC, because that's what the proportionality theorem or the proportional division theorem says, that the line parallel to one of the sides divides the other sides proportionally. Okay. So we want to prove, our aim is to prove that this part, AD over DB, is equal to this part, AE over EC. If we can prove that, then we basically prove the theorem. Okay? So how can we show that this part is equal to this part? We need to show that this part here is equal to this part. Okay? And that's not too difficult because area of triangle ADE, area of triangle AD, that's already a common triangle. So obviously it's the same triangle. So all we need to do is show that area of triangle DBE is equal to the area of triangle DEC. Okay, and we can say that. We can say they're equal. So we can say but triangle of area of triangle DBE is equal to the area of triangle DEC. We can just say it. The reason we can say that the blue triangle and the red one has the same area is because they share the same base. Okay, that's our reason. Share same base, or you can say common base. Share the same base, or you can say common base. Common base. Okay. Common, let's just write common base, I think it's better. They've got a common base, which is DE, and they got the same height. Okay, this triangle and that one has the same height. Okay, same height. Why do they have the same height? Because they're between the same parallel lines. DE is parallel to BC. Okay, so think about it. If two triangles, like this one, the blue one and the red one, has the same parallel lines, then the height for both of them must be the same. Okay, so that's important to put in this there. Common base, DE, same height, DE is parallel to BC. So because these two triangles are equal, we can now say therefore area triangle ADE over area triangle DBE is equal to the area triangle ADE again over area triangle DEC. Okay, we can say that now because we showed that these two triangles are equal and this is a common triangle. Okay. So that means we can say, therefore, if we can say this, and let's just say our reason for saying this is because triangle area of triangle ADE is a common triangle. Okay, so that's the one thing. And area, so it's common, yeah. This one is we can just say it's common. And you can also say that we showed that area of triangle DEE is equal to the area of triangle DEC. Okay, that's why we can say these two are equal. Okay, so therefore, because they are equal, it means that this is proved. So we showed that this now is equal to this, which means this part must be equal to this. So that's our conclusion. Therefore, AD over DB must be equal to AE over EC. Okay, so just to go through it again, we showed that this is equal to this. Okay, we showed they are equal. Okay, that's what we did here. And therefore it means that this part must be equal to this part. Those two must be equal. Okay, so that's what we did there. Okay, and that means they're proportional. Okay, and now you can say, sometimes if you do the whole proof, you can say, well, I showed it for this one and this one and that one and that one now. What about if they draw the line here, parallel there, parallel to this base? Or what if they draw the line there, parallel to this base? Okay, so you can say similarly, you can show, in the end, to be safe, you can say, well, let's just say this line also. Similarly, it can be proven, okay, that, yeah, if you draw a line here, okay, that those sides are also in proportion. That, let's say the other sides are also in proportion. The other sides also in proportion. If you draw a line parallel to this one, or if you draw a line parallel to that one. Okay, but depending on the question, in the exam with the proof, they might just give you this line and say, prove that this one over this one is equal to this one over that one. That might be the... So you must just read what are they asking with the proof. Are they asking you to prove the whole thing? But I've never seen them ask you to prove the whole thing. Normally they just give you one line. Then, like I said, they might put it in here. And then you must just imagine this whole thing is turned like that. And then you do exactly the same thing. You just do all these steps. Okay. Then it shouldn't even be necessary for that last part. Okay.